All right, welcome to part 3 of the lecture video. So we said that we want to adapt the SOHCAHTOA method in calculation of our rafter. Okay, in this case, you can see that this rafter over here is the same as our hypotenuse. Okay, take a note of that. Very good. So what are we going to do from here? Let's pull down our SOHCAHTOA to serve as a memory aid. Okay, in solving the work. So we are going to write over here SOHCAHTOA. Okay, very good. So means that opposite over hypotenuse, means adjacent over hypotenuse, and the toa means opposite over the adjacent. In this case, in calculation of the rafter, which one do you think is going to be more suitable for us to be able to calculate for it? It's as simple as that. It is the what? Cost. Okay, it is the cost, this one. So we are going to adapt the cost in the calculation of our rafter. Okay, very good. So let's quickly put that down and see how best we can proceed. So from here, that is going to become what? Our cos theta. Since this is a memory aid, let me just underline it nicely. We say in measurement of construction work, you can use what? Different color pens. Exactly. So we say we are adapting the cos. So this is going to become what? Our cos theta is equal to what? Adjacent over the what? Hypotenuse. Adjacent over the hypotenuse. Okay. But please take note that the hypotenuse over here is the same as our rafter. Okay. The hypotenuse over here is the same as our rafter. Maybe I should just go to a different sheet and then write that for you to see. So we are saying that our hypotenuse in this case is the same as our rafter. Good students can do well to jot this down to serve as a memory aid, okay, towards the future. Very good. Let's proceed. So from here, what are we going to do next? Let's just do our substitution. And what is the angle? The angle is what? 25 degrees. Okay, this is it over here. So that is the angle in which it was what? Pitched. Very good. So let's proceed. And that is going to become cos theta. That is going to give us cos theta to be equal to what? Or better still, cos 25. Cos 25 is equal to, and what is the value of our adjacent? 3225. You see? Yes, this value over here. This value you are seeing over here is the value you are going to write over there. You see? Very good. So you put that down. Very good. Okay. So after your calculation, what are you going to get? If you do the change of subject very well, you realize that if you do the change of subject very well from here, you realize that your H is just going to be what? 3225 over what? Cos 25. Yes. Because this is going to multiply this, and at the end of the day, if you make H the subject, you are going to get 3225 over cos 25. You see, as simple as that. So this is going to give us cos, or let me say this, if you simplify this is going to result us to get what? Our H to be equal to what? 3225 over what? Cos 25. You see. So let's all quickly simplify this and see how best everybody, please, let's all punch this. Let's all punch this together. Good. So if you punch this, you realize that you are going to get age. If you punch this on the calculator, you realize you are going to get your age to be equal to what? 3558.39. Okay. So that's if you run that, it's just going to become what? 40. Okay. So that is let's write it together. 355 point or 3558.40. Okay. 0.40. As simple as that. As simple as that. So from here, what are we going to do next? If you want to write it in meters, you could convert it and also write it in meters. Okay, that is, you just divide it by 1,000. So you write 3558.40 divided by 1,000. Okay, and that is going to give you what? 3.56. Okay, so this over here is in millimeters. This over here is in millimeters like this. If you want to write it in meters, then this is going to become what? Your age. It's just going to be 3.56 meters. As you are seeing over here like this. Okay, very good. Very good. So at the end of the day, we now know the length of our rafter. Okay, we now know the length of our rafter, as I was telling you over here. You see this rafter, the age which is the rafter, we now know that the value of it is equal to what? 3.65. Okay, that is 3.65 meters. Exactly. So you can see the value of your rafter over here. 3.65 meters. That is the length. Okay. But if you take note that the rafters we are talking about, they are plenty. Let's go to the roof framing plan and you see. The rafters are many. So how many rafters were used? You see that the rafters, they are plenty. Okay. They are the members you see running like this. Okay. The members you see running like this. Yes. Okay. Yes. So we want to know by the length of one. The length of just one member, if you take just a single unit, is 3.56 meters. Okay. So this is supposed to be 3.56 and not the other way around. 3.56 meters. Yes. So that is it. That is the length of one. Okay. So now we want to know the number of rafters that were used. Okay. But take note that if you come over here from the specification, what are they saying? They are saying that the rafters, the dimension is what? 150 by 150 sawn hardwood at what? 1,200 watt centers. Okay, so if you want to know the number of rafters, what can we do? Good. Let's see how best we can investigate that. So what we are going to do next is that we want to know the number of rafters as 1,200 centers. Okay, very good. So that is it. So this is number at 1,200 center to center. Okay. Yes. So we want to know the number of rafters that were used. Okay, good. First of all, what is the length? What is the length? The length we saw initially was what? 13350. Okay, let's go to the roof framing and you see that value. This is it over here. you see the length of the building, and that is the length of the whole roofing. Okay, the length of the roofing from the roof framing, and that is the length of the roof framing. So we've placed down the length. Okay, we want to know the number of rafters that went in there. When we finish, we'll come and count and see whether we'll get the same numbers. Yes. So the length, let's put down the length over here. The length is equal to what? 13350. You see, good millimeters. You see, but we are going to what? Less the roof is. You see the roof is. The roof is what? 6. The roof is at 75. Okay, the roof is at 75. The smaller ones you are seeing over, it's just very, very, very small from here to here. This small one, the roof is, so that we can have the real framing itself. Okay, so that we can have the real framing itself. Let me show you the roof if from the cross section. So you see it over here. It's just a very, very, very small one. This is it. This small if over here is a 75 millimeters you are seeing. You see, so it is at both sides. One is here and one is here. So if we remove the roof, it means that now we can see the framing itself. We can get the roof framing. Okay, so we are going to less the hot roof is. Yes. So we said a hot less roof is. So let's less that one. So the word is less. Okay. So less means we are hot subtracting, if you can remember. So we are lessing roof what is. So the roof is, we said that they are 75, but what? You see that you realize that they are 2. So that is going to be what? 2 times 75. Okay. 2 times what? 75. And 2 times 75 is going to give us what? 150. You see? Exactly. So that is how it's going to be. So finally, this is going to give us what? 150. You see? So that is how we are going to less from 13325. Exactly. 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 So if you less this, what are you going to get? If you less this, what are you going to get? You're going to get 13200. That is, you are going to punch 13350 minus what? 150. And that is going to give you 13,200. Okay. Yes. So let's all do that together nicely. And that is going to give us what? 13200. Okay. As simple as that. But you realize that this answer that we have gotten, this is just the hot total distance. But this is just the total length of what the roof framing itself minus the roof is. Okay. But we have to, if we want to know the number of rafters, then we have to divide by what? 1,200 center to center. That is this number that I highlighted for you. You see, the one I'm highlighting in yellow, 1,200 millimeters center to center. That is the center to center in which the rafters are placed within the length of the hut building. And so if you take the roof framing plan, you see, so the rafters are in it like that. You see, but they are placed at 1,000. That is 4 feet intervals. Okay. So let me write it over here. 1,200 millimeters is equal to 4 feet. 1,200 millimeters is equal to what? 4 feet. Okay. Yes. And 1 feet is equal to what? 300 millimeters. So you can jot that somewhere to make life easy for you. Okay. Good. So we are going to divide by that center to center. Okay. In division, what do we say we do? So we are just going to apply one of the rules we learned initially. Okay. And that is we are going to write hot 1 over hot 1,200, which is going to multiply the 13,200. Okay. So that is going to be 1. That's just going to be 1 over hot 1,200. 1 over 1,200 multiplying hot this. Okay. And finally, that is going to give us what? Multiply 1 over hot 1,200 times, or you can take the inverse of 1,200 times what? 13,200. And you see the value you get. You realize that you're going to get what? 11. You're going to get what? 11. But we said that what? Let's add 1 for wastage. You understand me? We said that let's add 1 for wastage. So if you add 1 for wastage, then you realize that it's going to become what? 12. Okay. So add 1 for wastage. So let me put the rule over here. So we said that what? Add what? 1. So we are adding 1. Okay. Yes, for wastage. You know the wood, if they go and buy the wood, some may get rotten, or because of the cutting measurement and all that precision purposes, we have to always add 1 for wastage, so that even if one breaks accidentally or something, still we can be accurate. Okay. Yes. It's always better that you over measure than under measure, because if the material does not reach, when the client has to go and buy for that, he didn't make budget, he didn't make arrangements for that. So you realize that that's what delay the work. Do you understand me? So we said that we want to add what? 1. Okay, that is wastage. So this one over here, I'm just adding it for wastage. Add 1 for wastage. So that is it. So at the end of the day, if you add 1, what are you going to get? You realize that you're going to get what? Oh, it's now going to be 12. Okay. Yes. So finally, you're going to get what? 12 number. So the number of what? Rafters that we are going to use is what? 12. Let's go and count to see if what I'm saying is true or not. So we go to the roof framing plan. I'm going to zoom this very well, and then we all take time to what? Count it. Do you understand me? Yes. So we are all coming to take time to count this now. So this is what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You see that it has reached 12. Very, 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 very good. So that is it. So now we know that we are going to need what? 12 number of what? rafters. Okay, good. So we have to just go and do our squaring, and then we are good to go. But you know that the rafters that I'm talking about, the calculation we did is for only one side. Oh. So we know that at this side, it is what 12 number of rafters that will go. But I realize that we have two faces. Okay, and the faces we are having, this is what face one, and this is what face what two, and this is what the second face. You see, so if it is 12 number of rafters that will be at phase one, then if you want to know the total number of rafters you are going to need, so we know the total number of hooks you buy, then we multiply the hot 12 times hot. So it's going to give us what 24. Do you understand me? So 24 number of hot rafters is what we are going to buy. Okay, or 24 number of hot 50 by 150 stone wood. That is what we are going to require. Very good. Very good. But we want to convert that into what? We want to convert that into the total length. You understand me? We want to convert that into the total length. That 24 number, I want to know it is in meters. So if you want to know that total length in meters, what do we do? Good. So we are going to multiply the two sides that I told you about, phase one, phase two. You see phase one, phase two. That is phase one, phase two times what? The 12th number of rafters. Okay. Yes. The 12th number we're having over here times the length. Okay. Yes, times the length, the real framing length itself, which was what? 3.56. Okay, good. So let's do our squaring and let's proceed. So over here we're going to write 2 times 12. Okay. Times what? 3.56. 3.56. Okay. And what is that going to give me? That is going to give us 85.44. Okay. So 2 times 12 times 3.56 is going to give us what? 85.44. Okay. So let's put it down and then we proceed. So that is going to be 85.44. So 85.44. You see? So as simple as that. As simple as that. So we are done. Okay. Now the only thing I'm going to do is we go to our description. Okay. In our last lecture, what did we say? We said that roofs are measured in what? In our SMM, we said that they are measured under G20. If you could remember, said that they are measured under G20. So that is the key code you are supposed to keep in your head for roofs. Okay. So if you take your SMM7, you just open the contents. Okay, you open the summary content and you go and look at what G. Okay, so we are using what G and H. Okay. So we are going to what G20. We are going to G20. Yes, so that is it. So I want to show you over here and then we proceed. This is our G20 and that is what we are going to open in the SMM7. So this is G20. If you can see G20 over here, you see page hot 67. Good. So this is our Gen 20 over here. So let's look through. This is our classification table. Let's look through. So you can see over here, the ninth one is what? Our roof members. And since it is, the angle is what? 25. This angle being 25, it tells us that it is a pitch roof. So the description we are going to use is what? J20 .2.1. You see. So these members are measured in what? They are measured in what? Meters. You understand me? I'm saying they are measured in meters. Someone is confused. Take note that the 2 is just as a result of the 2 faces. And then the 12 is this 12 number we're having over. It's only the 3.56. That is the length of the what? Rafter. That is what? In meters. So that is why it carries that unit. So it is measured in what? Meters. SMM7 said it all. So our description is going to be what? We are going to use the specification. Always remember to use the specification. Okay. So we are going to say that what? Roof framing member pitched. Okay. As roof framing member pitched. 50 by 150 sawnwood impregnated with what? Preservative. Okay. Because you should take note that they are saying over here that all roof timbers are to be impregnated with preservatives. Okay. So you have to do your description according to the what specification. Okay, so let's just quickly put the specification down, and then we proceed. So this is going to be what? Roof framing members. Roof framing members pitched. .50 by 150. Okay, millimeters. Sawnwood. Yes, you write it. If you don't do your description, you will lose marks. Impregnated with preservative. So once you put this down, you are done with your description. As simple as ABC. As simple as ABC. So we are done with the description. You see, we are done with the description. So let me just use 2 screens. If you want to take screenshots, maybe you want to have a clear view of how far we have come. Yes, so that is how far we have come. Okay. So we said that the first thing I'm supposed to do, we put your project title, the date, drawing number, scale, SMM7. You come and do your takeoff list. Okay. So we are done with the rafters. The next thing we're going to do is the purlins. Purlins is not going to take much time. Hangers are not going to take much time. Snowdens, we are done. Rafters is just the one that is a bit technical. But once you get the understand, you get the concept, you are good to go. Okay. Yes, you are good to go. On this note, my name still remains Megabyte the physicist. Don't forget to see me in groups, in person, one-on-one, in case you encounter any challenges related to the study. Remember to subscribe to my YouTube channel, hit on the notification bell so that anytime I upload a video, you can get a notification. Thank you. Also, don't forget to like the videos, comment, and ask more questions to enhance your understanding. Okay. Good students should always remember to have a book, a pen, and a calculator beside them so that they can also practice what we are doing along. Okay. Failure to do some of these things will result you in a whole lot of challenges. Okay. When you practice it, it becomes part of you. Thank you very much. So let's proceed. So the next thing we're going to measure for is the second one, which is the what? Is the second one, which is our purlins. Okay. So let's just put that down and let's do a simple calculation for the purlins. Then from there, we can consider the hangers. Okay, so from page 1, see, you see that the next thing over here is what? Purlins. Okay, we are done doing for what? Rafters, as you just saw over here. Okay, so we are going to Purlins. Good. So as I was saying initially, what is the length of the building? The length of the building is what? 13350. You see. So the length is equal to 13350 millimeters. Okay, good. 13350 millimeters. Good. And what next? So from here we are going to what? We are going to less. Okay. From here we are going to less. So we say that less. We are going to less the ifs, the roof ifs. Okay. I'll show you the purlins right now. So we are going to less the what? Roof ifs. Okay. So as we did at the initial stage. So this is going to be what? There are 2. Okay. So it's just 2 times what? 75. So that is going to be just 2 times what? 75. You see. And that is going to give us what? 150. Okay. Very good. So that is 150 what? Millimeters. As simple as ABC. As simple as ABC. Okay. Mm-hmm. Okay. So from here, what are we going to get? Let me show you the purlins. Okay. The purlins are, if the rafters are this one's going, the purlins are just this, the horizontal ones. Okay. The purlins are the horizontal ones. The purlins are the horizontal ones. The purlins are the horizontal ones. Okay. So the horizontal ones are what? 1. These ones you are seeing moving in the horizontal direction. So you want to know the number of them too. Okay. So this one we are removing the what? Roof eaves. You see. So the roof eaves are both sides. So we remove 75 from here. We also remove 75 from here. Then we can get the real what? Framing itself. Okay. So that we can get a real framing itself. So let's quickly go. Let's quickly go, and then we see how best we can proceed. Okay. So after letting the roof is, what are we going to get? It's just the same as what we did initially at the initial stage. Okay. So after this experiment, you realize that we are going to get 1320. Okay. So that's going to be 13,200, just as we did initially. Okay. Then from there, we want to know the number at what? The purlins, we want to know the number of them. Okay. Take note that if you come to this drawing, that is the specification. We say that all roof members are impregnated with preservatives. Good. But the purlins we are talking about, this is the purlins over here. So the purlins, their dimension is what? 50 by what? 50 by 50 millimeters. Okay. 50 by what? 50 millimeters. Sawn hardwood at the keyword over here is what? At 900 millimeter center. So over here, what are we going to do? We're going to do at 900 millimeter center, just as we did for the initial one. Okay. So over here is going to be what? So we're going to write number at 900 millimeter center. Okay. So that is number at what? 900 millimeter center. Number at 900 millimeter center to center. Number at 900 millimeter center to center. Okay. So that is the number at 900 millimeter center to center. So it's just the same calculations we did over here initially. That's the same thing we are just still going to apply. So look at, take note. We said that the rafter is equal to what? 3558. Okay, that is the length we had for the rafter. 3558. Let's go back. I'm saying this because I want to show you something. Okay. This over here when we calculated for the rafter, how did we get? I want you to see it one last more time. We had what? 3558. Okay, this is the value we had when we calculated for the rafter. 3558.40. Okay, good. So let's proceed. So over here, now we know that the length of the rafter is equal to what? 3.56 meters. That is if you want to just talk about it in meters. Okay. So we are going to just divide the 900 center to center within the rafters. Okay. So that we can know the exact number of purlins that will go on the hot rafters, because you know that the purlins are placed on the hot rafters. Okay. So let me show you. The purlins. Okay, we want to know the number of purlins that will go on the hot rafters. We want to know the number of purlins that will go on the hot rafters. Okay, so to know the number of purlins that will go on the rafters, we have to take the length of what? One rafter. If we take the length of one rafter, then we divide it by the hot, the 900 center to center. In that case, we will know the number of hot purlins that will go on hot, just a rafter. So if we take one rafter that is running in this direction, okay, a rafter that is running in this direction. Now you want to take a purlin, which is the blue color pen I'm using now. You want to know the number of purlins that will go on it like this. Okay. And they said that the purlins are placed at what? 900 center to center. You see. So we just divide that. So we are going to take the whole number, 3.558. That is, we take the whole number. Okay. Then we do the division. So let's do that together. So that is the rafter. We know that the rafter over here, our rafter is equal to what? 35580. Okay, 3558. Okay, let's consider the whole number. Millimeters. Okay, good. So we are just going to what? Divide that. Do you understand me? We divide that by the 900 center to center. As simple as that. So take note that I also said that the H is equal to what? The rafter. Which is equal to that number you are seeing over here. But in the calculation, what did we get? We had what? 3558 point what? 40. Okay, very good. Very good. So from here, we are going to put this same value down, and then we are going to consider the whole number. Okay, and then we divide by 900 center to center. We use it to do our calculation. We are good to do. Okay, so this value, we divide the center to center by it. Okay, that is the 900 you are seeing. So that is going to become what? 1 over 900. So that is 1 over what? 900 times what? 13350. As simple as ABC. So this over here, finally is going to give us what? Do the calculation, and what are we going to get? That is, you are going to punch 1 over 9, okay, times 3558. And that is going to give us what? That is going to give us 395.333333. Okay, so in millimeters, that is what you are going to get. So you're going to get 3, 9, you're going to get 395.33. Let's say 33, okay, millimeters. But in meters, it's going to be a different value. Okay. So this value we're having over here, but if you want to write it in meters, so let's say 395.33 divided by 1,000. Okay. So this is not the answer. You're supposed to get 3.95. Okay. You're supposed to get 3.95. I just made a correction. So that is, you're going to get 3.95 over here. Okay. So this is going to be what? 3.95. Okay. 3.95 millimeters. Okay. So you're going to get 3.95 millimeters. So that means that four number of what? So this one, it's not going to be millimeters, it's going to be numbers, because millimeters is going to cancel what? Millimeters. You see, millimeters is going to cancel millimeters. So that is it. Okay. Millimeters is going to cancel millimeters. So this is going to be what? 3.95 number. And this is equivalent to what? 4. This is equivalent to what? 4. So we say that what? Therefore, 4 number of what? for 4 number of purlin, but we have to add 1 for what? Wastage. Okay, we have to add 1 for wastage. So I write this as a whole number. So you see, I'm going to write what? 4.00. But for numbers, you can't write it in decimals, you see. So I'm going to write 4 number, okay? Then you less what? 1. We add 1 for wastage. Okay, we add 1 for wastage. So this number, and we say that let's add 1 for wastage. So from here, we are adding 1 for wastage. So we add 1 for wastage. Very good. So we are adding 1 for wastage. Okay. So this is it, 1. Okay. So if we add 1, realize that what are we going to get now? We are going to get 5. Okay, so the total number we are going to, the total number of purlin that is going to go on what? The total number of purlin that is going to go on 1 rafter is what? 5. Okay. Yes, so that is 5 number. 5 number. Okay. 5 number. As simple